It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything, from telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions. But they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project. Figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000 from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must. That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
You might think high-tech telescopes let us see every inch of the moon, but that's not true. At our satellite's south pole lie giant craters untouched by sunlight for eons. stuck in pitch black, colder than Pluto, and almost impossible to explore. However, maybe we have to if we want to explore space. Because the darkness hides some must-have resources that will make life and long-distance travel in space possible. Yes, we're talking about water locked up as tiny crystals in the lunar soil. Now, water in space is always good news. You've probably heard that scientists are also obsessed with finding it on Mars. If the red planet has any type of water below its surface, it raises the exciting possibility that life might have existed there. Even microbes would be the biggest discovery in human history. That's why rovers are poking around Martian craters and drilling into the soil like some very dedicated space gardeners. But as incredible as water on Mars would be, water on the Moon might be even more valuable to us in the short term. The reasons are simple: the distance and the gravity of the Moon. We can reach our satellite in 3 days. That's almost nothing. It takes at least 7 days to reach New York from London via a cruise ship. But more important than the length of the trip is the possibility of using the Moon as a pit stop. Stop, refuel, and relaunch so we can resume exploration. The gravity on the Moon is only 1/6 as strong as Earth's. That's not just useful for endlessly entertaining yourself by jumping around. This difference means that launching rockets from our satellite is much easier compared to launching them from Earth, which requires a tremendous amount of fuel just to break free from the atmosphere. For example, the Saturn V rocket, which took astronauts to the Moon during the Apollo missions, was made up of more than 90% fuel just to get off the ground. On the Moon, however, it's much easier to launch a rocket. That means that we could carry heavier loads with less fuel. It's like being able to take a bigger suitcase on your trip. If we can find and use ice on the Moon to create rocket fuel, it would turn our satellite into a practical and affordable stop for exploring the solar system. Not to mention that by applying some basic chemistry, we could extract oxygen from water and use it for breathing or rocket engines. Also, astronauts would need water to drink and grow crops on the lunar base. So, what do we know about the latest discoveries? For a long time, scientists thought the Moon was completely dry. But in 2009, NASA basically crashed a rocket into a crater. It caused an explosion of ice and vapor, like fireworks, and finally confirmed that the Moon had some kind of water. But how much? Well, enough to matter. The data suggests there could be hundreds of millions of tons of water ice locked up in the Moon's polar regions. Some estimates roughly say 1.3 trillion pounds. That's about the same weight as 460 million cars. Not exactly lakes, but still a lot. And there still could be more. This water could also contribute to uncovering cool scientific secrets. The ice is ancient, which makes it like a time capsule from the early days of the solar system. Studying those frozen molecules might tell us not only how water got to the Moon, but also how it appeared on Earth. Anyway, what's all that water doing on the Moon? How did it get there? Scientists assume that some of it probably hitched a ride on comets and asteroids billions of years ago. Many of those space rocks carried ice, and some of that water ended up in the polar regions. Another source could be the way solar wind interacts with the lunar surface. In any case, however this ice appeared on the Moon, the real trick is where it ended up, inside its polar craters. And while we can find the ice not only in the craters at the South Pole, that's where the largest, most stable reserves are believed to be. Some of those craters are enormous. One of the most famous is called the Shackleton crater, and it's over 13 miles wide and more than 2 miles deep. That's almost twice as deep as the Grand Canyon. The Moon barely tilts on its axis, only about 1 degree, so the sun never peaks over the rims of those deep polar pits. The temperatures dip to around -400 degrees Fahrenheit there. Any water or chemicals trapped in that frozen dirt just stay there, locked away like in a freezer. Something really cool is that at the South Pole, you have parts that are stuck in the perpetual darkness, but some nearby mountain ridges get almost non-stop sunlight. Scientists call them the peaks of eternal light. They are perfect for setting up solar panels, while still being close enough to access the icy treasures hidden below. The poles of the moon are the only places in our solar system we know of where perpetual day and night exist side by side. But the eternal night isn't just fascinating, it's dangerous. The terrain out there is absolutely unforgiving. We can't even simulate something like that on Earth. We don't even know what it looks like from the inside. It's worse than exploring the northernmost part of Antarctica while wearing a blindfold. So now that we know this, is that potential water even obtainable? That question is probably worth several trillions of dollars. Yes, there's water over there, but getting to it won't be like scooping ice cream from a bowl. What we're really talking about are microscopic ice crystals mixed into lunar dust. To make use of it, machines would need to dig and heat up the soil, then capture the vapor before it escapes back into space. And then there's freezing. Even assuming a human or rover could safely reach the bottom of a crater, it'd be almost impossible to navigate. Batteries and equipment probably wouldn't last, and it's impossible to use solar panels or electronics down there. They'd freeze in minutes. However, NASA's Lunar Reconnaissance Orbiter uses all kinds of radars and sensors to sniff out what the crater looks like inside. And now there's an even sharper tool, shadow cam. A camera so sensitive it can capture details in light 100 times dimmer than what our eyes can see. Basically, the ultimate night vision device. With it, we can finally map those pits without even setting foot there. That's why engineers are thinking up all sorts of clever solutions. Some concepts involve nuclear-powered rovers with headlights strong enough to carve through the dark. Others want robots that rappel down crater walls or hop across the floor like pogo sticks. There are even ideas for drills that could melt frozen soil and trap water vapor like condensation on a cold soda can. The silver lining is that this water isn't going anywhere. Until we improve our technology, the supply will wait for us. That being said, space agencies are already making advancements. In fact, more than half a dozen new missions are lined up over the next few years. NASA's Artemis program is getting ready to send astronauts back around the moon and then down to the South Pole. China's Chang'e 7 is planning to check out those dark craters. And private companies like Firefly and Blue Origin are gearing up to deliver equipment and experiments. Now, here's a bonus, lesser-known fun fact. The moon smells. When Apollo astronauts brought lunar dust into their landers, it mixed with the oxygen inside and ended up smelling pretty strong. They said it was like burnt gunpowder or fireworks. Lunar dust has nothing to do with gunpowder, but its particles are highly reactive. After sitting in space for billions of years, they reacted instantly with oxygen in the cabin, creating that smoky odor. Future explorers are definitely going to notice that smell too, since lunar dust tends to stick to everything. Let's hope that, aside from everything else, scientists will work out air fresheners for the moon base.
Technological progress does not stand still, and over the past decade, the resolution of images of the lunar surface has improved greatly. Many pits have been discovered on the surface, and some of them are really impressive in size. The largest are hundreds of feet deep. However, technology is not yet advanced enough for us to study the bottom of such pits in detail. That's why a recent discovery is surprising. It turns out that huge pits can extend deep into the rock of the moon. It's a groundbreaking discovery. Let's figure out why. So look at this giant underground cave. Leonardo Carrere and Lorenzo Bruzone from the University of Trento were thrilled to finally confirm the existence of such structures on the moon. They analyzed images taken by the mini RF instrument on board the Lunar Reconnaissance Orbiter in 2010. The original images didn't have excellent resolution, so the authors had to do a huge amount of work, using modern data analysis and modeling techniques. But first things first, why does it all matter so much? Well, instead of building homes on the surface of the moon, we might be able to live inside these natural caves. They could offer protection from dangerous things like harmful space radiation, extreme temperature swings, and even meteorites. According to planetary geologist Wes Patterson from Johns Hopkins, even though we'd still have to bring materials from Earth to make those caves habitable, using them would be a lot easier and cheaper than building bases on the surface. Based on the collected data, the cave is about 150 feet wide and up to 260 feet long, which is just a bit smaller than a football field. It's located in a deep pit called the Mare Tranquillitatis Pit, which likely formed when an ancient lava tube collapsed. Although the moon has no active volcanoes today, billions of years ago, its surface was covered with lava that flowed through valleys, carving out these tubes below the surface. Over time, some of the lava tubes became unstable and collapsed, creating pits like the one in question. NASA's Lunar Reconnaissance Orbiter, LRO, has already found more than 200 of such pits on the moon. It means there could be hundreds of hidden caves waiting to be explored on our satellite. When publishing their findings in Nature Astronomy, the researchers suggested that the caves could offer future astronauts a safe place to live and work, protecting them from the moon's extreme conditions. And extreme they are. One of the biggest challenges of living on the moon is its temperatures. The lunar surface gets extremely hot during the day, reaching about 250 degrees Fahrenheit, and then the temperature drops below minus 200 degrees Fahrenheit at night. But inside the caves, the temperature could stay much more consistent. A separate study done in 2022 used computer simulations to predict that some of those caves could maintain a comfortable temperature of about 63 degrees Fahrenheit. Much easier to manage, right? Unfortunately, getting to the caves won't be easy. The Mare Tranquillitatis Cave is over 400 feet below the surface, at the bottom of a steep slope covered in loose debris. It would take some clever engineering to get up and down that slope. The options could be using jetpacks, a lunar elevator, or some other kind of technology. We must find a way to transport astronauts safely. There's also a lot more to discover. Radar technology could help scientists find even more caves and lava tubes on the moon. In the future, a spacecraft with higher resolution radar could even map the insides of the pits that LRO has already found. According to the researchers, this kind of complete survey could help them figure out the best locations for future lunar bases and other explorations. And there's another potential bonus. Those caves could contain water. Scientists have already found frozen water on the moon, under the surface, and in permanently shadowed craters. Tiny amounts are also scattered across the lunar dirt. Water is a critical resource for any moon base, and finding it in the caves could make the idea of living there even more realistic. All in all, this discovery could be a game changer for lunar exploration. Living in natural caves on the moon might be a more practical and safer option than building something on the surface. It could also bring us one step closer to making the moon a place where humans can live and work for the long term.
Sometimes, when you look at the moon, you see a face smiling down at you from the moon's surface. Of course, this is an illusion, but many people see it, and that's because its surface is shaped by some sort of lunar seas and highlands. From our point of view, we see these as light and dark patches. These seas are dark parts, and large hardened lava plains formed because of volcanic eruptions that happened a long time ago. The light regions are actually the mountains and the highlands. And people all around the globe see these lunar patches as a smiling face or even some other shapes. Our brain tends to play with things of this nature, and that's a phenomenon called pareidolia. It's when you see familiar faces and shapes even though they're not actually there, similar to how you can see a face in a slice of toast or shapes while watching the clouds. And in the northern hemisphere, people see a face in those different lunar seas. The eyes are the sea of serenity and rain. The sea of clouds represents his mouth, while the seas of islands and vapors form his nose. But that's just one way to interpret this picture, and that mostly works in the northern hemisphere. If you live in the southern hemisphere, you see the moon the other way up. When they look at the moon, some see a person that looks like they're carrying a bundle of sticks. Or there's the shape of a woman. She wears her hair up and it has 2 jewels in it, and they see the left side of her face in profile. One of the craters is reminiscent of a shining diamond which, it seems, she's wearing around her neck. In some places, people may see the shape of a rabbit, whereas people from the Pacific Northwest in America even have a story about the toad they see when looking at the moon. The story says there was a wolf that fell in love with a toad, And the toad didn't quite trust the wolf since it wanted to escape and didn't know where. It simply made one huge leap and landed on the moon. Now, do other planets have beautiful rainbows like we do? The ingredients for that are raindrops and sunlight. At the moment, we don't know of a planet with liquid water on its surface, and none have enough water in their atmosphere to make it rain. But droplets of some other liquid could refract light coming from the sun and spread it out into various colors. Titan is one of Saturn's moons, and the atmosphere there is rich in droplets of liquid methane, which probably form rain. The atmosphere on Titan is very hazy. That means that direct sunlight is not that common, but there's still a slight chance we could catch methane rainbows someday. If they really exist, they'd be similar to rainbows on Earth, but they'd be a bit broader because methane refracts light differently than water. There's a similar thing on Venus called glory. Scientists caught pictures of this optical phenomenon of sunlight falling on sulfuric acid droplets, similar to a rainbow. Jupiter is insanely big, around 11 times wider than Earth. Not only that, our planet is twice as small as its Great Red Spot, the raging storm that's been present on the planet for more than a century. Now, we owe Jupiter a lot. Its radiation is 1,000 times stronger than the lethal level for us, and the gravitational force is so powerful that it actually protects our planet from collisions. In some other planetary systems, giant planets like Jupiter can move around and migrate from the place where they were originally formed. They spiral inward and get closer to their stars. When they move around, they can cause a lot of trouble. When they get closer to their stars, they can swallow and destroy some innocent small planets or other celestial bodies that stand in their way. But if these giants remain far away from their stars, they serve as guardians of the planetary system. They protect the planets in the inner orbits and allow them to circle around a central star. Jupiter got the nickname vacuum cleaner of the solar system because it can eat up any comet or asteroid that comes close enough. It can also change their orbits and kick them out so they can't come back for a very, very long time. That way, Jupiter protects the inner planets, although sometimes it accidentally sends asteroids or comets into them, causing collisions like maybe the one that made the dinosaurs extinct 65 million years ago. Now, Saturn's rings are the most famous ones in our solar system. They are far-reaching, colorful, and highly visible. You can even see them using a backyard telescope. But some other ice and gas giants also have them too, like Uranus. It has the second most interesting set of rings in our solar system. There are 13 rings, and they're all made of very dark particles that are different sizes. They're most likely young, way younger than Uranus itself. One theory says high-speed impacts shattered one or more moons, and this may have been the matter these rings are formed of. There were way more particles of debris, but only some survived, and today are forming stable zones around Uranus, known as rings. Now, our planet lost 60% of its atmosphere when there was an asteroid impact that, as one theory says, probably created the Moon. The collision between Earth and a Mars-sized rock happened over 4 billion years ago. The debris from all that, collected in an orbit around our planet, eventually formed the Moon. Now, Venus is home to at least 37 volcanoes that were active recently, which is the first evidence that showed its interior is still geologically active. Previous research discovered that the planet's interior was warm, plus there were ring-like structures. Plumes of extremely hot material deep inside Venus rise through the mantle layer, and that's how these structures form. It's like how plumes form the volcanic areas of the Hawaiian Islands. But scientists think they were just a result of some ancient activities. They believe Venus has cooled enough and drastically slowed down geological activities in its interior by hardening the crust so much that all of the warm materials from deep inside can't get out to the surface. Speaking of volcanic eruptions, Jupiter's moon Io also has them. Our moon is pretty peaceful, but Io has hundreds of volcanoes, and it took the title of the most active moon in our solar system when it comes to volcanoes. If you could go there, you'd see plumes of sulfur that reach up to 190 miles into its atmosphere. Volcanoes there emit 1 ton of particles and gases into space near Jupiter, its parent planet, every second. This could be because Jupiter's strong magnetic field and gravitational force. Io's interior tenses up and relaxes as it orbits Jupiter, and gets closer to it and farther away from it, which generates huge amounts of energy, enough for volcanic activity. There are billions of comets in our solar system. Most of them are in the Oort cloud and the Kuiper belt. A comet generally consists of rock and ice, at least until it gets closer to the Sun. Then its exterior turns into a cloud of dust and gas. And that's why comets have their specific tails. Pluto's unique surface is a series of domes, peaks, and troughs on the planet's landscape, which may have been formed because of its many large ice volcanoes. Neither erosion nor some other geological activity has done that much, but its ice volcanoes actually push icy material up to the surface. There are also a couple of craters in this area of the hemisphere called New Horizons. Asteroid impacts probably caused these. Plus, these craters aren't that geologically old. Also, the interior of Pluto probably retained heat, which enabled matter rich in water and ice to deposit onto the surface. And those specific structures I mentioned before could have formed because the water was rising up from the interior of the planet and ended up being rapidly frozen because temperatures on Pluto are extremely low, in addition to atmospheric pressures. Uranus is the second least dense planet in our solar system. The least dense one is Saturn. Now, even though Saturn is 14.5 times as massive as our planet, it's still less dense than water. This means that Saturn would float in a pool if it was more than 37,000 miles wide, so the planet would have enough space to even be in there. Whoa, that's a big pool. Now back to Uranus. Since its density level is so low, you probably experience less than 90% of its gravity, assuming you could even set foot on its cloud tops. Now Mars has pretty crazy dust storms, the biggest ones in our solar system actually. They can blanket the whole planet and last for months. One theory says these huge storms start because dust particles absorb sunlight and warm the atmosphere of the red planet. Warm pockets of air form and they start flowing toward colder areas. This generates winds. These powerful winds lift more and more dust off the ground. This again heats the planet's atmosphere, creates more wind, and kicks up even more dust. Wow, better have a broom handy, maybe even two.
The large ball of fire thousands of miles away from us is the brightest object in our solar system, as well as the biggest. If Jupiter was the size of a basketball, then the Earth would look like a tiny little grape. But the Sun makes even Jupiter look like a joke. That big burning ball in the sky is made up of hydrogen and helium, and is 864,000 miles in diameter, making it more than 100 times wider than our little blue planet. It's 10,000 degrees Fahrenheit just on the surface, and 27 million degrees at the core. The Moon, on the other hand, is a little easier to grasp at around 2,160 miles in diameter, which is only less than a third of Earth. It might seem pretty big floating in the sky, but that's because it's the closest object to us. But what if the tables, or in this case, celestial bodies, have turned, and the Moon suddenly became brighter than the Sun? Let's explore several scenarios. Scenario 1. If the Moon becomes brighter than the Sun, the nights will be brighter than days. It means your sleep cycle will be disrupted. All nocturnal animals will be utterly confused. When is it time to go out and eat now? In the extreme north and south poles, the nights and days are for months on end. So people living in the area already have an idea of what it's like to sleep at 11 p.m. with the sun shining brightly above them. For the rest of us, it won't be easy. Let's say you're out camping and prepare an awesome meal and gear up for the dark nights. As you trek into the forest, you find a spot that has an awesome view of the lake and the clear sky above. It's 7 p.m. and you start a fire for some s'mores and get the telescope ready. The only problem is that when the sun begins to set, the moon lights up the sky even brighter. It's surprisingly not as hot as you'd imagine, since it's not direct sunlight, but regardless, it's still pretty hot. Scenario 2. Temperatures will surely rise either way. That means snow will melt away faster than you can go, What's going on? The snow on the mountains will be the first to melt, followed by the polar caps. With so much heat, the sea levels will rise and take small remote islands scattered across the ocean underwater. Coastal towns will go down and everyone will live closer inward. This will likely cause a chain reaction in the world economy. There will be no more winters, which means no more winter activities like skiing, snowboarding, or snow fights. Animals and plants all around the world will be affected. The world will turn into a large desert. Water will get scarce over the years, but people will find a way to preserve it. Scenario 3. You're sitting behind your desk, bored. You're losing business. People aren't buying as many sunglasses as you thought. But when the moon suddenly becomes brighter than the sun, and everyone needs to wear those glasses 24/7 when heading outside, you can't keep up with the demand for sunglasses, so you hire more people and grow your business. You eventually become the best sunglasses business in the country. They don't recommend looking up at the sky at any point of the day or night. Cities are covered with large visors to reduce the brightness every day. Sunglasses will come in different sizes and shapes for different times of the day. Some will be like goggles strapped around your head, while others will be like large helmets. Scenario 4. The moon's atmosphere is so thin that it can't contain anything in it. Just like over deserts on Earth, there are no clouds to bring some rain, which is why it's always hot or cold. Yeah, the biggest desert in the world is the whole continent of Antarctica, which is a cold, barren desert, contrary to what people think of the Sahara Desert. So if you still want to land on the moon, you better think twice now. People who are working at the International Space Station will have to find a new office. The moon will be too bright to bear, considering how close they are. If the moon is just brighter than the sun without the heat part, then the space station will only require adjustments to keep the light out. The reason why we see the moon in various shapes is because of its position in relation to the sun. The moon doesn't rotate, unlike Earth. It's kinda glued to us and is always showing the same side. So, depending on the moon's position during the month, we'll have a super bright night during the full moon, and relatively shiny nights during the rest of the month. Scenario 5. If the moon became brighter than the sun, it would produce more heat than the sun and probably become larger. Gravity on Earth would change significantly because of the moon's new size. The whole orbit structure would change and affect the celestial objects floating in space. Planets would soon begin to orbit around the moon. Earth might move further away from the sun. If that happened, then everything would have to readjust to the radical changes in gravity. Weak gravity means buildings wouldn't have a solid foundation to sit on and would eventually collapse. Bridges and large monuments would also fail to hold up. People wouldn't be able to walk properly and would do it in a funny way. Scenario 6. In many of these scenarios, I mentioned how the moon would be brighter than the object emitting light, but in this case, the sun would have to come from the moon reflecting from the sun, which means that the sun would have to be twice as bright as it is now. If the sun got 100 times bigger, it would shoot out more rays, which can be damaging and throw off a lot of radiation, harmful to every living thing on Earth. The gravitational pull of the sun might attract more planets to orbit around it and cause other objects in space to join the orbit. The planets would be partying in our galaxy club, and we might be thrown off our orbit course. Of course, this would pose a bigger risk to everything on Earth as things would get hotter and drier than before. Scenario 7. If we're talking about the moon getting brighter, we can also assume it would get closer to Earth than it is now. The brightness won't be the problem here, as gravity will cause major changes on Earth. But every day, 24/7 will be high tide. It will be so extreme that there will be constant floods in every coastal town. All islands will be submerged, which will increase the population of inland cities. Marine life will be having the time of its life when water overtakes the land. Boats will have to be re-engineered for new conditions as well as submarines. Air travel will be the priority, but large cruise ships will look futuristic and have an extra build to sustain the harsh waves. Nighttime will be pretty bright on regular days. It will raise the global temperature, which will melt down the snow, causing the sea levels to increase even more. Comets and other celestial objects will be drawn to a closer gravitational pull. so we will always have to look up whenever we go outside. But no worries, the moon is still up there as it is for a very long time. The Earth and the moon's relationship is complicated. Luckily, we only have one natural satellite. Other planets in our solar system have multiple moons revolving around them. Some are so huge that they're the size of Earth. Imagine several of those affecting our home, but that's a topic for a completely different story.
NASA has some incredible plans for the moon. For example, their next ambitious lunar program, Artemis 2. They've set their sights on landing astronauts, including the first woman and the next man, on the moon by 2024. Artemis is all about building a sustainable presence on the moon. They're planning to establish a lunar gateway, a sort of space station in lunar orbit, which will serve as a jumping-off point for lunar landings. And let's not forget about the cool lunar landers. Scientists are developing the mighty Space Launch System rocket, which will launch the Orion spacecraft carrying astronauts towards the moon. Then there's the Human Landing System, a snazzy lunar lander that will gently touch down on the moon's surface, allowing astronauts to explore and conduct amazing scientific experiments. And NASA isn't going alone this time. They're teaming up with international partners, like the European Space Agency, to make this lunar dream a reality. But all these wonderful dreams might be ruined by something that seems super small and insignificant at first. Picture this: no atmosphere, no air to breathe, and suddenly, a mysterious haze and radiant beams of light appear at sunrise and sunset. It's as if the moon is putting on a celestial show. But there is a twist to this beauty. During the Apollo 17 mission in 1972, this beautiful sight made one of the NASA astronauts, Harrison Schmitt, sneeze and made his eyes water. He called it lunar hay fever. This mysterious fever affected all 12 moonwalkers. From sneezing fits to stuffy noses, those astronauts experienced symptoms as if they caught a cold. It took days for the reactions to fade away. This event led to a discovery about lunar dust and its darker side. When scientists found out about these rays, they rolled up their sleeves and delved into their origins. And here's what they discovered. Those radiant bands of light were actually caused by sunlight sneaking through layers of teeny tiny lunar dust. The dust was composed of small particles and sharp glass shards and was lurking everywhere. And it turned out that this lunar dust was a sneaky villain. It brought a whole host of problems. Astronauts who found themselves with impaired vision were just the beginning. The troublemaker went even further, damaging precious machinery and causing electronic malfunctions. It even had the audacity to corrode components and smelled like burnt gunpowder inside the spacecraft. Yikes. It clings to everything, coating surfaces like a mischievous blanket. It can clog up equipment, get into delicate machinery, and even mess with astronauts' spacesuits. In 1972, things got really hairy again. The Apollo 17 astronauts faced a nightmare. After just 22 hours of gallivanting on the lunar surface, their spacesuits suffered irreparable damage. Yes, you heard that right. Irreparable. The dust diminished astronauts' mobility, making it harder for them to move around and perform their moonwalks with grace. And no matter how hard they tried to clean it off, it clung on for dear life, leaving the spacesuits in a sorry state. So, as you can see, it poses some serious challenges for future moon missions. But our intrepid scientists aren't giving up. To solve this problem, they have to understand how lunar dust forms and why it's so darn clingy. They found out that it all begins with meteorite impacts. When these space rocks crash into the moon, they generate a fine dust that fills the air. Sometimes these impacts even cause minerals to melt, forming sharp glass shards that mix with the dust. Talk about a moon makeover. The dust is also filled with silicate, a material commonly found on volcanic planets. Silicate inhalation can cause serious lung problems for Earth's miners, so you can imagine the trouble it can cause on the moon. A recent study found that even a scoop of replica moon dust was toxic enough to destroy up to 90% of lung and brain cells exposed to it. But it gets worse. The low gravity on the moon allows those tiny particles to float around for much longer, penetrating deeper into the lungs. Imagine breathing particles 50 times smaller than a human hair for months. That's a recipe for trouble. And you see, on the moon's surface, things are a bit different than here. There are no rainstorms or strong gusts of wind to blow this dust away. There is also no atmosphere to protect the surface. So without the natural forces of wind and water erosion like we have on Earth, these dry particles stick around persistently. And to make matters more electrifying, the moon is constantly showered by radiation from the sun. This exposure gives the dust an electric charge. The solar winds create positively and negatively charged particles. The particles then buzz around, repelling each other and giving rise to the European Space Agency has gathered a team of experts to study the lunar dust. They're working with simulated moon dust mined from a volcanic region in Germany to understand its behavior and effects. Engineers also need to find a way to protect future astronauts and equipment. Engineers in NASA want to create spacesuits that can survive not 1, not 10, but a whopping 100 extravehicular activities on the lunar surface. That's like spending 800 hours out there, exploring and having a blast. Besides that, NASA initiated the Breakthrough, Innovative, and Game-Changing Idea Challenge in 2021. It was open to clever university students from all over the world. These young minds put their thinking caps on and unleashed a wave of innovative solutions. For example, they proposed using special fibers that conduct electricity, inspired by fluffy chinchilla hair. Just like how chinchillas stay dust-free, these fibers would help keep the lunar dust at bay. A furry friend lending a helping paw, isn't that adorable? Another bright idea involved an electrically charged brush activated by UV radiation. It's like a magical wand that zaps away the dust with a flick. Abracadabra, lunar dust be gone. And let's not forget the fabric inspired by clever insects. These insects have pollen-collecting structures that repel unwanted dust. So our ingenious students thought, why not mimic that? They designed a fabric with similar properties, creating a shield against the sneaky lunar particles. What's remarkable about these ideas is that they all use the power of charge to fight the dust. They cleverly repel it from the spacesuits, keeping them clean and protected. And even though all these ideas sound pretty great, scientists in NASA unleashed another, even better solution: carbon nanotubes. It's a great way to revolutionize spacesuit fabric. What makes these carbon nanotubes so special? Well, they possess some amazing superpowers. First off, they're superconductive, meaning they can carry electricity like nobody's business. It's like having a lightning bolt trapped inside a microscopic tube. Not only that, but these carbon nanotubes are tougher than the toughest meteors. They have the strength to withstand the harsh lunar environment, where even a speck of dust can cause trouble. Imagine having a suit made of a material that's stronger than Superman's cape. So, NASA's scientists decided to weave these extraordinary carbon nanotubes into the spacesuit fabric. The electrodes were carefully integrated into the outer layer of the fabric, making it a force to be reckoned with. But how do they banish the lunar dust? Well, here comes electrifying science again. When activated by a special alternating current, the electrodes create powerful electric fields. These fields work like magnets, repelling both charged and uncharged dust particles away from the spacesuit. Picture this like a dance party, where the dust particles are the uninvited guests, and the electric fields are the bouncers, swiftly escorting them out. Thanks to this technology, lunar dust doesn't stand a chance against our astronauts. Also on the bright side, the lunar soil can be used to make bricks for shelters. It can also help extract oxygen for astronauts to survive on the moon for long periods of time. When life gives you lemons, make a lemonade, right? So, let's cheer on our NASA Dream Team as they embark on this epic lunar quest. Let's hope that they succeed in their findings, and the next moon mission won't be a big problem. Stay tuned.
The Moon. A beautiful, natural satellite with some mysterious dark splotches. We always see only one side of it, so we're used to this image. It's hard to imagine the Moon looking any other way. But it used to be different. Oh ho ho, it used to be so different. Picture this, a huge incandescent satellite in the sky that is causing constant tsunamis. I suggest we go very far into the past to see what the Moon was like many, many years ago. The Moon formed around 4.5 billion years ago. At that time, our green-blue planet was still a red-hot, insanely unstable piece of rock flying in space. We didn't have the Moon yet, and a day on our planet only lasted 6 hours, which meant only 3 hours of daylight. Volcanoes erupted all over the place, releasing poisonous gas into the air. and a bunch of meteorites regularly crashed into the planet. At the same time, 4.5 billion years ago, the so-called Big Splash occurred, or as scientists call it, the Giant Impact Hypothesis. It claims that once an object the size of Mars crashed into Earth. Mars is about 2 times as small as our planet, so the blow wasn't too bad, but it was quite catastrophic. This powerful impact tore off part of the outer layers of that Mars-sized object and Earth. The very core of this space body merged with Earth's own dense core, and a huge number of fragments of Earth flew into outer space. So, this was the beginning of our moon, or, saying in a scientific way, the process of differentiation has begun. This is the process all planetary bodies go through at the beginning of their lives. Since the impact was very hot, its heat carried away most of the gases and liquids from the broken pieces of Earth. Only a relatively dry stone surface remained. So yeah, there is water and gases on the moon, but in very small quantities. The gravity of our planet was strong enough to make all these hot stone fragments stay in its orbit, and they gradually began to stick together. The chemicals they contained were distributed in layers. Iron, which was heavier, sank deeper inside, and lighter elements formed the surface. In a short time, 100 years or less, the ring of steam, dust, and molten rock fused together. The largest clusters with the strongest gravity attracted more and more particles, gradually forming the moon. It looked like a red-hot bubble ball. Sadly, the nucleus of this newborn moon turned out to be very small. It lacked iron and other heavy elements to form into something substantial, like a planet. The oldest rocks of the moon probably formed in the ocean of magma. And when the moon gradually cooled down, it turned out to be a white, clean, and perfectly even ball. But it was still completely different from what we have now. To begin with, immediately after its birth, the satellite was located at a distance of only 13,500 miles away from Earth. This is 15 times closer than it is now, around 238,000 miles. It's scary to imagine how huge and bright the moon looked in the sky at that moment. The view was probably both beautiful and terrifying. And, of course, such proximity caused incredibly huge waves on Earth. The planet experienced regular tsunamis. Also, at that time, the moon was spinning very fast, and it wasn't turned to Earth with only one side. But, in general, Earth and the moon had a positive impact on each other. For example, it was the moon that made our day last 24 hours. Now, Earth's axis is mostly tilted 23.5 degrees from the plane of its orbit around the Sun. Without the moon, Earth rotated rapidly, but thanks to the satellite, the planet's tilt stabilized, which led to a wide and pleasant variety of climates on Earth. To be fair, the gravity of our planet also helped the moon. Thanks to it, the moon began to rotate more and more slowly while gradually moving away from us. Over the years, its orbit has moved far away from our planet. At the same time, the moon became tidally locked to Earth. This means that its rotation period coincides with its orbital period. Or, in other words, the moon moves around itself as fast as it moves around the Earth. That's why the moon always faces our planet with only one side. When the moon moved away, tides on Earth became calmer. Now, water could flow to the most remote corners of our planet. It was then that life appeared on Earth. But back to the evolution of the moon itself. What was happening on its surface after its formation? The next stages of the moon's development were childhood and adolescence. And as is usually the case at this stage, this period was insane. No wonder. About 4 billion years ago, the solar system was going crazy. During the first 600 million years of the moon's existence, large asteroids and comets constantly collided with it. Now, they were bothering not only our Earth, but also its satellite. These impacts were the most powerful in the history of the moon. They left many large craters, which were later filled with dark rock. So, Earth wasn't enough for you, huh, space? Once, a dwarf planet crashed into the moon. It was about the size of Ceres, the largest object in the asteroid belt between Mars and Jupiter. This explosion formed the SPA basin and also forever changed the appearance of the Moon. Can you see that dark spot on the far side of the Moon? Right there in this very south? This spot is called the South Pole Aitken Basin. Its diameter is about 1,600 miles. And yes, it was formed by the impact I've mentioned, about 4.3 billion years ago. This planet brought with it a bunch of complex and strange chemical compounds that scientists are now finding all over the far surface of the Moon. These compounds began to emit a lot of heat, melted part of the lunar mantle, and, oops, accidentally woke up volcanoes. The volcanoes began to erupt furiously. A huge amount of magma was distributed over the surface of the Moon. Many years later, it cooled down, leaving behind those famous dark splotches that we're so used to. They're called the lunar maria. There are much fewer craters there than on the lunar highlands. But for the last billion years, the Moon has been geologically inactive, except for occasional collisions with meteorites. In general, the appearance of the Moon changed forever as a result of these events, and, battered and tired, it entered adulthood. But even then, it couldn't get any peace. A bunch of meteorites decided to bother it again. Honestly, it wasn't that bad. There were many collisions, but all of them were quite small. They just left a bunch of craters and pits on the Moon and maybe damaged its mantle a little. Some of the collisions deepened already existing large craters. The Moon's crust was getting thinner and thinner over the years because of all the chaos going on. And now we call this upper part of the lunar crust covered with craters the lunar highlands. All those white and bright areas of the Moon, the highlands. But in the end, the universe finally calmed down, for now at least, and the Moon began to look the way it does today. There are still many things we don't know about Earth's natural satellite. There are moments in its history that scientists still can't accurately explain, but they're continuing to study our beautiful satellite. The data about the Moon is useful to people not only for its own sake. It gives us a more complete picture of both the history of our solar system and space as a whole. So, let's hope that one day we'll be able to find out everything there is to know about the Moon.
There's something happening inside the Moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the Moon is made up of layers: a crust, mantle, and core. However, the Moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The Moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the Moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the Moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the Moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the Moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this. the Gravity Recovery and Interior Laboratory, and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the Moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the Moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the Moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the Moon's gravity as they go. It's like they were feeling the Moon's invisible pull in different places. If the Moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the Moon, even if they can't actually go there. And the spacecraft intentionally crashed into the Moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the Moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The Moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the Moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the Moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the Moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the Moon itself, it also tells us more about other celestial bodies. If the Moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the Moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the Moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the Moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the Moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the Moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the Moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush. Because apparently, precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl, catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Carmen Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching. Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite.
They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the Moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the Moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the Moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the Moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the Moon's formation around 4.5 billion years ago. On the far side of the Moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the Moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the Moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the Moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the Moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
Imagine stepping out of your spacecraft and setting foot on the surface of the Moon. Under your feet, the ground is covered with a fine material that looks like powder. That's lunar dust. You look around and take a lungful of fresh air. It smells very different from the air on Earth, but still nice. Now, unfortunately, this is a highly unlikely scenario, and one of the reasons is that the Moon has almost no atmosphere. Earth's natural satellite is too small, less than 2% of our planet's mass. That's why it doesn't have a magnetic field strong enough to keep an atmosphere. But even if the Moon had it, solar winds would immediately pull it away. But if you could visit the Moon 3 or 4 billion years ago, you'd see a very different picture. At that time, the Moon most likely had an atmosphere. It formed at the times when powerful volcanic eruptions were rocking the satellite. Gases spread all over the Moon's surface. It happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurling high into the air, falling to the ground, forming lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists on Earth got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggested the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days it's around 240,000 miles. That's why the Moon looked much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. Neither was I. At the same time, the most recent studies have confirmed that our Moon actually does have an atmosphere. It's composed mostly of hydrogen, neon, and argon, and contains some very unusual gases, like potassium and sodium. You can't find them in, let's say, the atmospheres of Mars, Venus, or Earth. Sadly, such an atmosphere isn't suitable for us oxygen-dependent creatures. But guess what? There's loads of oxygen on the Moon. I know, it must sound confusing, but the thing is, this oxygen isn't in its most common gaseous form. It's trapped in a layer of rock and dust covering the surface of the Moon. This layer is called the regolith, and it contains up to 45% oxygen. So, does it mean that if people learned how to extract this oxygen, we would be able to live on the Moon? Not so fast. The oxygen in those rocks is very tightly bound into the minerals, and to break these components apart, we'd need tons of energy and special equipment. But if people managed to start this process, the Moon would deliver quite a lot of oxygen. Now, there's a theory that the Moon might have been formed during a collision between Earth and another planet. This planet must have been smaller, the size of Mars. It probably happened around 4.5 billion years ago. Another theory claims that the Moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet, and that's how the Moon appeared in the sky. And the least exciting theory claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. These days, the Moon is the 5th largest natural satellite in our solar system. It's also one of the densest, second only to Jupiter's satellite Io. Most likely, the Moon has a tiny core, no bigger than 2% of the satellite's mass. About 420 miles wide, it consists mostly of iron and sulfur. The Moon's surface is dark, even though Earth's natural satellite is the brightest object in the night sky. But in reality, its reflectance is just a bit higher than that of asphalt. You might have heard that the Moon, along with the Sun, causes tides in the oceans and seas on Earth. The satellite's gravitational pull creates something called the tidal force. It makes the water bulge out on the sides that are the closest to the Moon and farthest from the satellite. These bulges are what we know as high tides. But what not so many people know is that the Moon also causes rocks to rise and fall. just like it does with water. Of course, this effect doesn't look as dramatic as ocean tides, but it's still noticeable. Earth's solid surface moves by an inch or so with each tide. Now, not only does the moon cause tides on our planet, but it also slows down its rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. You should really cut those. If one day it floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Since the moon doesn't have an atmosphere, nothing protects it from extreme temperatures. It gets incredibly cold on the night side, minus 390 degrees Fahrenheit. Meanwhile, the sunny side is literally boiling, with a temperature of 250 degrees Fahrenheit. Another thing the moon can't protect itself from without an atmosphere is meteorites. That's why the surface of the satellite is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. The moon is less seismically active than Earth. That's why these craters and other ancient formations stay in perfect condition for centuries. But even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. They start several miles beneath the surface. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say the moon has become around 150 feet skinnier than it used to be several 100 million years ago. So, how does it work? Well, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike a grape, the moon doesn't have any flexible skin. Its surface is hard and brittle. So, as the moon gets smaller, the crust cracks and breaks. Its sections get pushed over neighboring parts. Researchers are sure that such faults are still active and likely responsible for the quakes shaking the moon. Some of these quakes are pretty strong, up to 5 on the Richter scale. When you look up at the moon, you always see the same side of Earth's natural satellite. Like our planet, the moon rotates around its axis, but this rotation lasts around 27 days. This is the same time the moon needs to orbit Earth. Such a phenomenon is called tidal locking. Before space exploration started, people had never seen the other face of the moon. They didn't know what the far side looked like. While the near side of the moon is mostly large plains covering impact basins, the far side is rugged and cratered. The crust is thicker there, with less evidence of volcanic activity. Oh, by the way, the moon isn't perfectly round or spherical. It's shaped like an egg. When you're looking at it, one of its small ends is always pointing at you. Yep, right at you. This is the reason why the moon's center of mass isn't its geometrical center. In reality, it's a bit more than 1 mile off-center, like a poorly made golf ball. Wow, the NASA hotline is ringing off the hook. The call center operator is all sweaty from stress. They barely have time to answer the phone, and all the messages they get say the same thing. There's something glowing on the moon. Indeed, hundreds and thousands of amateur astronomers were watching the moon that night. And suddenly, there was a bright light on it, as if someone had lit a powerful spotlight on the surface. Scientists immediately began to look for an explanation to this phenomenon. They first thought it was simply the glow of an airplane flying between the observers and the moon. But then it wouldn't have been seen by so many people from different parts of the world at the same time. The next suspects were the Starlink satellites. Theoretically, one of them could have played a cruel trick on amateur astronomers. They could have mistaken the small satellite's light for a flash of light on the moon. But then again, if the satellite were the culprit of this mess, the flare wouldn't be static, but moving. While some scientists continue to search for an answer to this mystery, others decide to investigate the phenomenon in more detail. For this purpose, they have built a new telescope north of Seville, Spain. The conditions there are quite suitable for observing the moon. The telescope has 2 cameras, controlled remotely from the campus in Germany. If both cameras pick up any unusual phenomenon on the surface of the moon, it will quickly zoom the telescope there to see what's going on. It'll also require advanced artificial intelligence to teach the cameras to distinguish between the unexplained phenomenon on the moon and the light of an airplane, a satellite, or a small meteorite that just entered the Earth's atmosphere. While the telescope is doing its investigation, we already have a theory that may explain the appearance of such bright round flashes on the moon's surface. So, the moon influences the tides of the seas and oceans on Earth with its gravitational force. But the Earth can affect the moon in the same way. Only the force will be 32.5 times stronger. While the moon orbits the Earth, at one point it may be as close to our planet as possible. Then the force of the interaction will be greatest. At this point, tidal forces may force cracks in the surface of the moon to open and release gas from its interior. A powerful jet of gas will lift the lunar dust with it, and what we see as a bright flash through our telescopes is really just a fog of dust, which is round and reflects sunlight well. If you look at it from a distance, it really does look like a flash. As the dust rises, we think there's been a small explosion, and that flash gradually fades as the dust settles down. These things happen all the time on the moon's surface. They're called transient lunar phenomena, and besides lunar flashes, much more mystical and bizarre things have happened. Back in 1178, 5 monks claimed to have seen the moon, being in the shape of a horn, begin to split in 2 from an upper point. Then fire and sparks began to blaze from the place of separation. It was as if a dragon were spewing flames. In the next moment, the moon began to pulsate and then returned to its calm state. This phenomenon was repeated more than 10 times, and the flames took different shapes each time. When this nightmare was over, the moon turned black. It wasn't until the 20th century that scientists tried to explain the phenomenon. They theorized that a large asteroid collided with the moon at the time, and it was this asteroid that should be blamed for creating the Giordano Bruno crater, 15 Brooklyn bridges wide. But in that case, millions of tons of fragments from the asteroid would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would definitely have been in the archives. But that didn't happen. Now the phenomenon the monks observed seems questionable. Perhaps they did see an asteroid fall, only it was falling on the Earth itself, and they perceived the light from the burning meteorite as something sinister happening on the moon. Or maybe the monks were simply imagining things. There's no witnesses to this event other than them. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's horn-shaped, and this occurs most often in the Aristarchus crater. The flashes come and go very quickly, almost like lightning. In fact, this is electricity. Tidal forces are to blame for this too. They cause mechanical stress to build up in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. There can also be starbursts on the moon. We can blame this on meteorites that fall on the surface. Because the moon has no atmosphere, asteroids that approach it don't burn up. Having a lot of weight and speed, they cause an explosion on impact. And here on Earth, we see it as a starburst. For example, on May 13, 1972, there was a meteorite impact of 1,000 tons of TNT near where Apollo 14 landed. If we lived much earlier, we might have witnessed constant bright flashes on the moon's surface. All the craters there are formed by such meteor strikes. So imagine the fireworks that were there years ago. And a lot of those meteorites were even useful too. They brought water with them. Yes, there is water on the moon. NASA confirmed this fact after studies with the SOFIA telescope. It was mounted on an airplane. The observations were made from the upper atmosphere of the Earth. At such an altitude, the dry air allowed the telescope to see even the smallest details. Water might have been in the craters at the poles of the Moon. These places have never seen light, and the water there might be encased in ice. But Sophia found water on the sunlit surface of the Moon. Of course, it's only H2O molecules that are present in the dust layers, but that's something. If we manage to collect all this water, we'll get very little of it. In comparison, the Sahara Desert has about 100 times more water than we found on the Moon. But an even more unusual phenomenon is happening there right now. The Moon is actually rusting, just like a piece of old metal. For rust to appear, we need iron, water, and oxygen. Lunar soil has enough iron in it, and as we've already learned, there's some water too. The last piece of the puzzle is oxygen. Everyone knows there's no atmosphere on the Moon, and we can't breathe there, but oxygen is still present. The solar wind brought it there. The wind from our warm star moves at an extremely high speed. It scrapes oxygen from the upper parts of our atmosphere and carries it further through space. Eventually, the wind with the oxygen molecules reaches the Moon. Voila! All the ingredients for corrosion are in place, and the iron ore on the surface of the Moon begins to take on a reddish hue. If this process goes on long enough, in the distant future, the Moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from that corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Other strange objects that can be seen on the Moon were left there by humans. Between 1969 and 1972, 12 people visited there as part of the Apollo program. In all, there were 6 landing sites where the astronauts left a bunch of stuff behind. Besides a couple of dozen satellites and spacecraft that fell or landed softly on the Moon, there's a lunar rover, some United States flags, a family photo of one of the astronauts, and even 3 golf balls. And the first 2 people to be on the Moon left behind a whole pile of stuff. When they were about to go home, they took a lot of soil samples and rocks with them. And to carry it all away, they had to get rid of everything unnecessary on board the lunar module. The TV camera, the sample collection tools, the science equipment, and even the armrests from the seats. The astronauts stood outside the lunar module for a full 8 minutes and threw out a whole mountain of unnecessary items. If you collect all these objects and debris that we left there by 12 astronauts and put them on the scales, it will show about 199 tons. It's like 3 heavy armored tanks or 3 large passenger planes. Strange, but true.
An asteroid broke off the Moon and now it's super close to Earth. Does it pose a danger to us? Kama'oalewa, also known as 2016 HO3, spins super quickly as it orbits near our planet. Let's call it HO3 for short. Astronomers found it on April 27, 2016. Compared to other asteroids, it's tiny. On Earth, though, it would be the size of a small building, or about half the size of the London Eye Ferris wheel. They discovered it in Hawaii, and its name roughly translates to a fragment of something that seems to wobble. After some study, they realized that this asteroid might be a chunk of the Moon that got blasted into space. There's a part of the Moon called Giordano Bruno crater, named after an Italian philosopher, that guy who had to pay quite the price for his ideas. If you look at it from space, Giordano Bruno stands out because it's surrounded by some rays of material. They're super huge, stretching over 93 miles and are still bright. This means that an enormous boom once happened there. There's an interesting story about this. In 1178, 5 monks were traveling in Canterbury, England. Suddenly, they saw something strange happening on the Moon. They said it looked like the Moon was splitting, with flames and sparks. Then there was a darkening that spread all across the lunar surface. In the 20th century, scientists found these records and thought that these monks saw the formation of the Giordano Bruno crater. But later it turned out that the crater is about 4 million years old. And thank the stars, because such a massive impact, if it really happened in the 12th century, would have gone crazy on our planet. It would have caused a huge meteor storm on Earth. In any case, our HO3 is most likely a piece of the moon that broke off during that impact 4 million years ago. Luckily, there's no need to panic about it. When astronomers spotted this sudden moon piece, they quickly tracked its orbit. Turns out, it won't collide with us anytime soon. It's going to be our quasi-satellite for at least 300 more years, meaning it'll follow a path around the Sun that keeps it close to Earth without colliding. Its orbit is wild though. It seems to be constantly looping around our planet in some pretty unique loops, moving closer and going away, up and down. And then somewhere in the 24th century, it will go even more crazy, switching to a horseshoe orbit, slowly going away from us. Could HO3 collide with us someday? Maybe, but that would happen over millions of years, when it would leave its current orbit and collide with Earth, Venus, or even the Sun itself. Or maybe entirely ejected from the solar system. Even though it's one of the closest asteroids ever discovered, it's also one of the smallest and most stable ones. This discovery also opens up some exciting ideas about life in the universe. We see that rocks can travel between celestial bodies. There is a theory that life could have been spread all across the universe by traveling on these rocks like on some space Ubers, or at least the building blocks of life like carbon. Maybe life even hitchhiked to our planet on rocks from Mars. HO3 probably doesn't carry any life, but the fact that it can travel for millions of years carrying stuff on it and feeling fine supports this theory. Astronomers want to send something to investigate HO3. Back in 2017, a group of students gave an idea of using a spacecraft for it. The China National Space Administration wants to send a robotic probe to HO3 somewhere in 2025. The robot should fly there, collect samples, and bring them back to Earth for study. Unfortunately, you can't see this asteroid in the sky with the naked eye. Its size is about 130 to 330 feet in diameter, so it would be too tiny and dim to see without a super powerful telescope. But there is an asteroid that you'll be able to see, and it will be insane. In 2029, a large asteroid will pass so close to Earth that it will be visible to the naked eye. Make sure not to miss it, because this is a once-in-a-thousand-year event. The asteroid is known as 2004 MN4, or Apophis for short. It's much bigger than HO3, about 1,210 feet wide. This will be the closest asteroid passage ever. This one actually caused some panic back in December 2004, all because there was a 2.7% chance that it could hit Earth in 2029. People were horrified. Even the name, Apophis, is inspired by an evil serpent from ancient Egyptian mythology. A huge monster that fought Ra and always tried to swallow the sun and destroy the planet. Luckily, when scientists got more data, they realized that it would pass pretty close to us in 2029, and we'd be able to see it in the sky. But then, it will just fly away like a chill asteroid. There was another worry though. That during its close pass, Apophis might travel through something called a gravitational keyhole. Basically, that it could travel through a specific narrow region of space which would accidentally alter its orbit. And then it would make an epic comeback in 2036, like the planet from the movie Melancholia. However, after some calculations, scientists ruled out this possibility as well. Apophis will still come quite close to us in 2036, but it will be about as far away as Venus is when it overtakes Earth. And then Apophis and Earth will just go their own separate ways. On average, an asteroid the size of Apophis is only expected to hit Earth once every 80,000 years. And if it did hit us, it would completely destroy a huge area, causing earthquakes and tsunamis all around the world. But it wouldn't cause an apocalypse or anything like that. You'd only be able to see Apophis from Europe, Africa, and Western Asia. So if you want to see it, you might need to travel. The asteroid will look like a fast-moving star in the night sky, shining bright enough to be seen without any special equipment. It would be easy to spot at night, though city lights might make it harder to see. Now, Can you imagine that these are not the only guys hanging nearby? Both HO3 and Apophis are part of the so-called Apollo orbit asteroids. These are the asteroids with orbits going around Earth, an entire group of dangerous fellas. Since they cross Earth's orbit, they have the potential to come close to or even collide with our planet. The first asteroid of this group to be discovered was 1862 Apollo, named after the Greek deity of the sun. It was first discovered in 1932, and the group was named after it. This one was even bigger, almost a mile in size. In fact, it's so huge that it even has its own tiny moon. Apollo crosses orbits of not just Earth, but also Venus and Mars. Fun fact, even though it was the first one of its kind, telescopes accidentally lost it out of view for over 40 years. So scientists went, oh well, let's just keep the count of things we can see. When Apollo was rediscovered in 1973, it wasn't the first asteroid on the list and got a big number in its name. Apollo will fly near us during the next hundreds of years. In 2075, it will be somewhere around Venus, but it should fly by as well. In any case, there's no need to worry, because astronomers are keeping a close track on these guys. If we were in any immediate danger, we'd have known. In order for an asteroid to totally destroy life on our planet, it should be bigger than 6 miles in diameter, like the one that helped to wipe out the dinosaurs 66 million years ago. But these guys are so crazy rare, we'd probably live on other planets by the time they arrive on Earth.
The first trip intending to land on the moon made by human mammals took 3 days, 3 hours, and 49 minutes. The Apollo 11 astronauts needed to travel some 240,000 miles to get there. Their plan was to touch down on a place on the moon called the Sea of Tranquility because it had good visibility and the terrain there was pretty smooth. Well, up until the last few moments of the flight, when all these big craters appeared that they had to avoid, they finally landed with just 30 seconds of fuel left. Ooh, that's called cutting it close. Hey, how would you like to land in your jetliner with only 30 seconds of fuel left? So, now you know. Later that day, July 20th, 1969, Neil Armstrong stepped onto the lunar soil, saying, "That's one small step for a man, one giant leap for mankind." The astronauts were planning to sleep before the first moonwalk, but they chose to go outside earlier than scheduled. They obviously couldn't sleep. I mean, could you? Since that first visit, our lunar satellite has accumulated quite a collection of memorabilia from Earth. Let's look at some of the most important and weird stuff that humans have left on the moon. Take footprints, for starters. I know they're not technically objects, but the marks left by Neil Armstrong and Buzz Aldrin do show that humans have been there, just in case someone or something else drops by. Since the moon doesn't have any wind or rain, the footprints should still be relatively untouched. NASA put in a lot of effort to make sure these footprints stay protected, as well as the location of the initial moon landing. Rules were set into place for future missions to make sure they wouldn't alter the initial site, as it's an important piece of history, kind of like a national park that you can't get to. Now, astronaut Charles Duke wanted to leave a photo of his family on the surface of the moon. If that didn't make him the best dad ever, I don't know what would. He did take his family to the moon, right? On the back of the picture, he wrote that he had come from Earth. He also added the date when he landed on the moon, which was April 20th, 1972. Now, there's a good chance that his family is no longer visible in the picture today. Because of the exposure to strong solar radiation, the colors in the photo have likely faded away by now. To this day, Charles Duke remains the youngest person to visit our moon. He was 36 years old at the time of his mission. Now, there are many flags on the surface of the moon too, but the flags left there must have had a similar fate to Duke's photo. They're most likely discolored by now. During each lunar landing, a flag was planted as a tradition started by Apollo 11. This tradition continued with all future Apollo missions. The flags were made using metal poles to stretch the flag out so they could be seen on the moon. But since there's no wind, they never move. Back in the 1600s, astronomer Galileo Galilei dropped 2 objects of different weights from the Leaning Tower of Pisa to show that the speed of the fall would be the same. In 1971, astronaut David Scott repeated the experiment on the Moon and proved Galileo's theory correct. He dropped a feather and a hammer at the same time, and as predicted, they both landed on the Moon's surface simultaneously. Fun fact, the feather came from the Air Force Academy's Falcon mascot named Baffin, with its permission, of course. These objects were both left on the lunar surface. Now, what about art pieces on the Moon? We've left some of those out there as well. The Fallen Astronaut sculpture was made by a Belgian artist and left behind by the astronauts of the Apollo 15 mission. It was a small statue requested by David Scott, the head of the mission. Scott said the statue was to memorialize the astronauts and cosmonauts who gave their lives for the advancement of space exploration. Meanwhile, astronaut Alan Shepard even played some golf on the Moon during his mission on Apollo 14. He brought a golf club head, yes, he got permission first, and attached it to a tool. Then he tried to hit 2 golf balls. Hey, it's hard to do in a clunky spacesuit. He did better on the second one. It's safe to say that he didn't bring the golf balls back, and they should still be there on the Moon. There's yet a message from Queen Elizabeth II there. The monarch prepared a message which accompanied Neil and Buzz to Tranquility Base during the Apollo 11 mission. It was written on a tiny disc the size of a coin and also featured messages from over 70 other leaders from all over the world. I'll bet the printing was really small. Her message said she was proud of the astronauts and their accomplishments and hoped their journey would benefit all of humanity. The disc was then placed where Armstrong and his team first landed on the Moon. After they returned, they met the Queen at Buckingham Palace. Their encounter was memorable too. Neil Armstrong almost couldn't speak to the Queen at all because he had a cold. Another astronaut named Mike Collins was so nervous about the protocol, he almost fell down the stairs. Now, some objects that exist today on the Moon weren't left there on purpose. One of the most interesting moments of the Apollo 11 mission was when Neil and Buzz were getting ready to go back to Earth. They had to chuck everything they didn't need so they wouldn't be weighed down at liftoff. They also needed to store all the rock samples they had gathered from the lunar surface. This created a toss zone that archaeologists could potentially study one day. Waste like this acts as a timeline for Earth's history, but it can also help us understand what happens to objects that spend a lot of time on the surface of the Moon. Now, most astronauts became pretty sentimental when strolling on the lunar dust, and who could blame them? They were thousands of miles away from their families. So that's why, in 1972, NASA astronaut Eugene Cernan wrote his daughter's initials, TDC, in the dust on the Moon, and gave a speech before leaving. He said, "We leave as we came, and hopefully we'll return with peace and hope for all." Unfortunately, this marked the end of the Apollo lunar missions. Technically, his daughter's initials should still be there on the surface of the Moon, just like all the astronauts' footprints. Can you believe it's been more than 50 years since people started exploring the Moon? No worries though, as NASA's been preparing for future lunar explorations for quite some time. This new mission is called Artemis, and it aims to build some sort of settlement out there. This way, the Moon can be studied in safe conditions for longer periods of time. For starters, NASA launched Orion, a spacecraft without a crew on board, to orbit the Moon and come back to Earth. This was a test drive. Before NASA transports people to the Moon again using newer technology, all safety measures need to be worked out and confirmed. But one day soon, Orion is going to take astronauts back to the Moon. One cool thing about this spacecraft is that it comes with a launch abort system, which is meant to keep astronauts safe in case something goes bad during the launch. It also features a special service module, which is like a battery that fuels and propels Orion through space. It also supplies astronauts with water, oxygen, and power, and provides temperature control. But Artemis also looks to build a long-term human settlement on our satellite somewhere around the 2030s. However, searching for a cozy place on the Moon isn't as easy as you'd think. Thankfully, NASA specialists produced an ingenious idea. They found some lava tubes on the surface of the Moon, and they have pretty steady temperatures inside. The main problem with the first moon landing back in 1969 was extreme temperature fluctuations. So these caves might be the perfect solution. Not only is the temperature in there suitable for humans, but they could also help shield astronauts from cosmic rays, solar radiation, and meteorites. It's also good news that we have similar structures here on Earth. Before we get back to space, we can study them to better understand those found on the Moon. Here on Earth, these holes form once the top of a stream of lava solidifies, and the molten rock inside drains away, creating this tube. Back when Apollo missions were launched, astronauts returning from the Moon claimed that moon dust, the gray sand-like dust covering much of the satellite surface, smelled and tasted, yes, they actually tasted it, like gunpowder. What the stuff moon dust is made of is nothing like gunpowder. About half of its composition is silicon dioxide glass from impacts with meteorites. They hit the surface of the Moon at incredible speeds. Whoa! The high temperature makes the topsoil fuse into glass, and the impact shatters it right afterwards, creating the gray and clingy dust. The rest of moon dust ingredients are minerals such as iron, calcium, and magnesium, while old-fashioned gunpowder consists mainly of saltpeter, charcoal, and sulfur. In other words, moon dust shouldn't smell like gunpowder, but it does. Besides, when astronauts brought samples of it back to Earth, there was no smell left at all. One explanation could be that the Moon is similar, in a way, to Earth's sand deserts, like the Sahara. It's extremely dry and arid. When you sniff the air in a desert, you don't smell anything. But if you get caught in the rain there, the moisture will raise all kinds of odors from the ground that were previously trapped in the dry sand. With moon dust, it might be similar. While on the surface of the Moon, it doesn't smell at all. Not that the astronauts could sniff at it wearing their spacesuits, though. But when brought back inside the landing module, the dust came into contact with moisture in the air and started emitting its strange odor. Another reason for this could be a reaction of moon dust to the solar wind. Ionized particles from the sun hit the bare surface of the Moon and stay there. There's no thick atmosphere to protect it from those ions, so they travel freely right to the ground. They're very lightweight, so they can fly off and sort of evaporate from the slightest of nudges. And when astronauts took the moon dust samples to the landing module, those particles could have started moving around and giving off the specific smell. This might also explain why the samples didn't keep their odor when brought back to Earth. Since the particles are so light, they might have flown off the samples already in the landing module. And when they were placed in airtight containers, there were little or no ions left on them. Another explanation is that those airtight containers weren't so airtight after all. Moon dust is basically very small crystals with extremely sharp edges. They unexpectedly made tiny cuts in the seals, letting in air and moisture, and so the ionized particles leaked out of the containers. Scientists believe they should study moon dust on the surface of the Moon itself to find out everything about its properties. Now, there are hundreds of thousands of craters on the surface of the Moon made by falling asteroids, but one of them drew a lot of attention. It turned out to not be just an impact crater, but a tube, looking most like an entrance to a cave system. Scientists found a specific echo pattern that suggested there was a hollow area beneath. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field. Researchers believe there could be an entire geological wonderland under the surface. It could be a good shelter for astronauts landing on the Moon, or even be a harbor for a lunar colony. No one ever managed to stay on the Moon for more than 3 days because of the conditions on the satellite. Wide range of temperatures, low atmosphere, no magnetic field would protect life on the surface from things like radiation or solar wind. Astronauts wear spacesuits. They can't protect them over long periods of time, but a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, and that's how an empty tube appears. Our planet also has lava tubes, but they're not as big as the one found on the Moon. Back in 1178, I wasn't around then, at least 5 people in England claimed they had seen the Moon split into 2 from its upper tip. It was in the shape of a crescent at the time of the event. When the crack widened, fire started blazing from it, which the single monk who chronicled it described it as a flaming torch sprang up, spewing out fire, hot coals, and sparks. Then the Moon started shifting around and pulsating, but soon stopped and turned a slightly darker shade. The event didn't receive much attention from scientists, though, until the second half of the 20th century. Researchers studied the chronicle and figured out there was a huge 14-mile-wide crater on the surface of the Moon at about the spot described in the book. Only a very large asteroid could have left such a scar on the satellite's face. And when they investigated it more closely, they found out it was pretty recent by astronomical standards. In fact, it really could have appeared about 800 years ago. But in that case, millions of fragments from the asteroid and the Moon would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would have definitely been in the archives. But that didn't happen. In addition, many scientists argue that the crater isn't as young as it might seem. The most popular and justified theory is that it's about 1 to 10 million years old. If it had appeared as recently as 800 years ago, parts of the surface of the Moon in and around the crater would still have been warm from the impact. The most likely explanation of what really happened back in 1178 is that observers were extremely lucky to see an asteroid falling towards the Earth and burning in our planet's atmosphere. The spectacle would have been incredible, and seen from a proper angle, the burst of the asteroid could have really looked like it was the Moon exploding. That would explain why there were so few witnesses of the phenomenon. The right spot to see the show, as they did, was only a couple of miles wide. As for real events on the Moon, water and oxygen were unexpectedly discovered on it not long ago. Water might have been brought to the satellite by asteroids hitting its surface, many of them carrying H2O molecules, and those that are left on the Moon in tiny amounts after the impact. There's precious little water there, though. By comparison, even the Sahara Desert has more of it than the entire Moon. Oxygen is also present as separate molecules floating around, so you still can't breathe on the Moon. Solar wind brought them there. Waves of energy from the Sun travel at extremely high speeds through space, scrape oxygen from the upper parts of our atmosphere, and carry it further. Eventually, the wind with the oxygen molecules reaches the Moon. And that's where something incredible happens. The Moon starts rusting. There's plenty of iron in the lunar soil, and when it's exposed to oxygen and water, it naturally rusts. Some parts of the Moon have actually already turned slightly reddish. They're regions where there's the highest concentration of molecules. If this process goes on long enough, in the distant future, the Moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from the corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Another unusual phenomenon is the blue and red lights on the Moon. They can be seen when it's crescent-shaped. The flashes come and go very quickly, almost like lightning. And in fact, that's what they basically are, electric bursts. Tidal forces are to blame for this. They cause mechanical stress buildup in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. But still, there's so far been no green cheese discovered there, or moon pies for that matter. Disappointing, I know. Time can stretch or shrink depending on where you are. Climb to the top of an extremely high mountain, and time will pass a teeny tiny bit faster than if you were down in a valley. That's all because of gravity and how it affects time. We hardly notice it in our everyday life, but for scientists and space agencies preparing to send people to the Moon, these minuscule differences in time really do matter. We'll get to answer the why question a bit later. Right now, a new space race is underway. Many countries want to establish long-term bases on the Moon. With humans up there, things like reliable timekeeping become crucial. The thing is, the Moon doesn't operate on Earth's time. A day on the Moon runs slightly faster than a day on Earth. The difference is about 56 microseconds, and it seems insignificant. But over time, even such a difference can add up, creating bigger issues. So, to keep lunar missions running smoothly and prevent things from drifting out of sync, NASA and scientists around the world are now dealing with a tricky challenge, creating an entirely new lunar timescale. NASA is supposed to start using it by 2026. It's the same year they hope to send astronauts back to the Moon for the first time in 50 years. But this new timescale is not just a Moon time zone. It's actually an entire system that will adjust for the Moon's faster time and keep everything synchronized with Earth's time systems. Only in this case will missions be able to run smoothly. You see, on Earth our timekeeping is already surprisingly complicated. It might seem like time should be a straightforward concept, but keeping accurate time is actually a precise science, especially when you consider how much timekeeping affects our daily lives. So, to keep global time coordinated, scientists rely on something called Coordinated Universal Time, also known as UTC. This global time standard is based on ultra-precise atomic clocks that scientists place in separate locations all over the world. Atomic clocks are cool because they measure time based on the consistent vibrations of atoms, so they're super stable and accurate. This helps scientists make sure UTC is the same for everyone everywhere. These atomic clocks also take into account that time moves slightly more slowly the closer you are to the center of our planet. So, atomic clocks positioned closer to the Earth's surface tick a bit more slowly due to stronger gravitational pull. This effect, explained by Einstein's theory of relativity, happens because gravity affects time. By spreading atomic clocks across different elevations, scientists average out all the tiny time differences caused by gravity. Also, for precise timekeeping, scientists occasionally add leap seconds to account for the small natural changes in Earth's rotation speed. It sounds pretty technical, but this process of keeping everyone on the same time helps make the modern world function. After all, precise timing is crucial for global trading, GPS navigation, and even internet communications. But time on the Moon works differently. Our natural satellite has a weaker gravitational field than Earth. That's why clocks on the Moon tick a bit faster. This difference means that lunar clocks are very likely to slowly drift away from Earth clocks if there's no correction. It can lead to big problems when astronauts need to keep in close contact with Earth or navigate around the lunar surface. NASA's solution is something called a lunar timescale. Scientists aren't going to adjust Moon clocks to match Earth exactly. Instead, they want to establish a unique system that measures lunar time accurately, but is also easy to convert back to Earth time. Think of it as creating a whole new framework just for the Moon. To make this lunar time system work, NASA is cooperating with international colleagues like the European Space Agency. Together, they're setting up what they call LunaNet. This lunar network will be a bit like the Internet for the Moon. It'll make sure all the lunar clocks work together and align with Earth-based time. Just like how atomic clocks around the world coordinate for UTC on Earth, clocks on the Moon will be part of this larger LunaNet network. Now, scientists are pretty experienced when it comes to managing time in space. Global Positioning System satellites, which orbit Earth about 12,550 miles high, have atomic clocks on board. These clocks tick faster than clocks on the Earth's surface because they're quite far away from Earth's gravitational pull. But then, how does GPS navigation stay accurate? It's because scientists have figured out ways to slow those clocks down to match Earth's time. This experience with GPS clocks is a great base for what scientists need to do on the Moon. In some ways, it might be even easier than managing GPS. Scientists can work with lunar clocks as they naturally are, instead of needing to adjust them to sync perfectly with Earth. By setting up accurate lunar time from the start, scientists hope to avoid some of the complications of managing GPS satellites. And now, here's the interesting part, or maybe more interesting. To keep lunar timekeeping a reality, NASA and its partners want to set up clocks both on the lunar surface and on satellites orbiting the Moon. Some of these clocks will be long-lasting atomic clocks, and others will be crystal oscillators. Those offer stability over short time periods. Together, these clocks will create a network that scientists will be able to rely on. Meanwhile, atomic clocks for space don't come cheap. They can cost a staggering few $1 million each. Luckily, crystal oscillators are more affordable, but they don't stay accurate over long periods. Once those clocks are set up, they'll work together as part of LunaNet, which will be NASA's framework for everything related to Moon-based time and data networks. LunaNet will act like an internet for lunar operations. Different space agencies will contribute to it, like how internet service providers work for us on Earth. But there's another set of challenges, and it's connected with the moon's rotation. Firstly, a day on the moon lasts much longer than a day on our planet because it takes the moon about 28 Earth days to make a full rotation. Plus, the moon's equator experiences about 14 days of sunlight, followed by 14 days of darkness, unlike Earth's regular day-night cycle. And at the moon's south pole, where NASA is going to establish future lunar missions, there are areas that stay lit or in shadow permanently. It might make it harder for astronauts to keep track of time. NASA and its partners hope to involve more countries in this project through international organizations like the International Astronomical Union. The idea is to get as many countries as possible on board with the lunar timescale, so that everyone exploring the moon is on the same page. Now, another really exciting thing about all this is that figuring out lunar time could help other future space missions, like trips to Mars. The experience and knowledge we'll get from setting up a lunar timescale are likely to serve as a blueprint for managing time on even farther planets. That's one of the reasons why scientists are taking this lunar project so seriously. As for astronauts living on the moon, a consistent, reliable time system will be essential, not just for navigation, but for everything from scientific experiments to day-to-day activities. NASA's Lunar Time Project is truly groundbreaking. It's the first step toward managing time as humans expand farther into space. And if they get it right, it'll mean that future astronauts won't just have Earth time to guide them. They'll also have a moon time, and even, one day, a Mars time too. Precise timekeeping matters both for the sake of scientifically understanding the passage of time on the moon and for setting up all the infrastructure necessary to carry out missions. Scientists are also eager to create a timescale from scratch because they can take everything they've learned about timekeeping on Earth and apply it to a new system on the moon. Well, I'm out of time, so bye! Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. what caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water, but that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one skywatcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the Moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago. But they appear much younger than expected. Typically found in clusters of 10 to 40. They're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger, and the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the moon. In its early years, the moon was just a molten world, shaking from intense volcanic and seismic activity. So, the moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out, 4.43 billion years ago. This was a huge turning point, not just for the moon, but for Earth too. After all, the giant impact that formed the moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The moon gradually cooled and contracted.
And now look at this modern-day rocky sphere illuminating our nights. But the moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the moon's continued activity. As it cools, the moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria. See these large dark patches on the moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the moon actually affect humans? In a sense, it can. The moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, there's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the moon's surface, grinding much of it into powder. Unlike Earth, the moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, constant exposure to solar wind has given the regolith an electrostatic charge, making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term moon missions much cheaper and more practical, helping astronauts live and work on the moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, There are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the Moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the Moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the Moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the Moon and the one farthest from the satellite. But that's not all. The Moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The Moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the Moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the Moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the Moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the Moon is shrinking as its insides are cooling. Scientists say that the Moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the Moon. It's shrinking and it's wrinkling. But unlike the grape, the Moon doesn't have flexible skin. Its surface is hard and brittle, so as the Moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the Moon? A recent study claims that it has a tail. And every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium. And our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the Moon's surface and further into space. For several days every month, the Moon remains between the Sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full Moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Haitian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggests it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler 186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler 186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it exovenus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable. Space. Dark, lifeless, and quiet, right? Well, apparently it's not always true. Recently, scientists have detected an eerie echo coming from the main black hole in our galaxy. It has high and low notes and sounds pretty otherworldly. What does it mean? Should we sound the alarm bell, siren, whatever? Sagittarius A star is our own supermassive black hole, sitting right in the center of the Milky Way galaxy where we live. You might know that black holes are the true monsters of our universe, gobbling up everything that is careless enough to come too close. If a massive black star runs out of its star fuel, it sometimes becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new thing becomes so strong that nothing can escape it, not even light. And so goes a black hole. We really can't see black holes since they devour everything, even light. But we can still figure out where they're located, all thanks to the existence of accretion disks. Want an explanation? Well, picture a black hole. The starving thing consumes all the matter that strays too close, squeezing it into a superheated disk of glowing gas. The black hole also bends light around it, which creates a circular shadow. That's what I mean. We can't see a black hole itself, but we can see the accretion disk surrounding it. It happens like this. First, the material gets caught in the black hole's orbit and squeezed into a razor-thin spinning band. Friction, heat, electric, and magnetic forces energize this disk, which makes the material glow intensely. The most massive black holes have such bright bands that they can outshine millions of galaxies. Inside this disk of glowing material, particles rub against one another. It slows them down and sends them straight toward the black hole's event horizon. If this friction didn't exist, the material would be orbiting the black hole for billions of years, like planets circling around their stars. Now, let's get back to Sagittarius A star. It's far less luminous than other black holes at the center of galaxies astronomers have observed. It means that, at the moment, our central black hole isn't actively munching on the matter surrounding it. What, is it catching some Z's? The answer is unclear. There's new evidence received by NASA's IXP telescope. It suggests that the seemingly sleeping giant woke up pretty recently, about 200 years ago. Ooh, that is recent. It snacked on gas and all kinds of cosmic debris within its reach. Why did it happen? And what did the black hole do after that? Sagittarius A star is the nearest to us supermassive black hole, just 25,000 light-years away from Earth. Its estimated mass is millions of times greater than that of our Sun. It sounds impressive, doesn't it? So, when scientists spotted relatively recent X-ray emissions of ginormous clouds of gas in the vicinity of the black hole, they immediately called on the IXP telescope to figure out what it may mean. What intrigued them most was how bright these clouds were. You see, most cosmic clouds, called molecular clouds, are dark and cold, with their X-ray signatures very faint. But that wasn't the case with this finding. Of course, there are a few theories concerning this phenomenon. One of the main explanations for why these giant molecular clouds are shining so bright is that they just echo a long-gone flash of X-ray light. It could mean that our supermassive black hole might not have been that dormant some centuries ago. After additional research, astronomers figured out that the X-rays coming from the giant molecular clouds were actually reflected light. And this light must have come from a short-lived and extremely intense flare that was produced either very near or right at Sagittarius A star. And the most likely cause of it is the black hole suddenly consuming a huge chunk of the material surrounding it. It happened around the start of the 19th century. It was most likely a sight to behold. Whirlpools of particles were drawn toward the black hole's event horizon, also known as the point of no return. The black hole started to ingest all this material, which resulted in brilliant bursts of X-ray light and echoes that we managed to translate into sound waves here on Earth. This discovery is crucial for understanding the processes happening to and around our supermassive black hole. We might also figure out what physical processes can potentially awake Sagittarius A star again, even if this period of activity is just temporary. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times the mass of our Sun. And two such giants have been recently spotted with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, mercifully also known as ALMA. Two gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. They aren't visible directly, but are surrounded by bright clusters of warm glowing gas and stars tucked close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger, black hole. Interestingly, such immense merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe these bright and compact regions where matter swirls around black holes. Imagine how surprised they were when, instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. And if before, experts thought that such galaxy mergers didn't really happen in our neighborhood, this discovery may mean that black hole binaries like this one may be much more common than we previously thought. And if pairs of black holes are so common, it can make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide there are in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in about 4.5 billion years. Oh, I can't wait. Now, have you heard that we might be living in a black hole? I'm not kidding. Such a scary theory does exist. See for yourself, black holes pull inside everything they see. But what if one black hole has already engulfed us long ago? Surprisingly, some physicists deem this theory somewhat plausible. For example, Dr. Nikodem Poplovsky, a theoretical physicist from Indiana University, states that everything that a black hole swallows may turn into a new universe inside the hole or on the other side of it. Who knows? Maybe our universe used to be a quite different place until it got pulled into a black hole. The theory of white holes is closely connected with the previous idea. While black holes swallow all the matter so that not even light can escape, white holes are something quite the opposite. These formations are believed to spit out everything that black holes have pulled in. In other words, a white hole is the hypothetical area of space-time that nothing can enter from the outside, but light and matter can escape from it. As for a black hole, on the contrary, you can only enter it from the outside, but